Namaste, greetings. My name is Dr. Shirish Ravan. I lead the organization called Earth Site Foundation based in India. Since long, I had a concern that geospatial information, and for that matter, the information we obtain from the space, the Earth observation, is not really reaching to the grassroots stakeholders who are involved in planning the development or planning the environmental projects, such as NGOs or local leaders who are the important stakeholders. So my organization is now making this technology very easy and accessible and taking this to the last mile user and the grassroots stakeholders. Prior to starting this mission, I worked with the United Nations Office for Drugs and Crime, and my job was specifically to monitor the opium poppy cultivation in Afghanistan using, of course, Earth observation and using geospatial information. I planned lots of counter-narcotic activities to combat the opium cultivation in Afghanistan. That was a very challenging task. And then I joined United Nations Office for Outer Space Affairs, which works for the global space governance, ensures that space is used for the peaceful purposes. So we had a committee for peaceful uses of outer space where I used to contribute. And I led the global program called UN Spider. It's a beautiful acronym. It's called United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. The acronym is UN Spider. Through this program, I traveled from countries to countries and offered the technical advisory missions to ensure that all the countries use space-based and geospatial information in all the stages of disaster management, right from building disaster resilience to the emergency response. So today we are going to discuss how geospatial data plays a crucial role in environmental communication. And obviously, we have to start from the very important three international frameworks to which the world is aligned. All the countries are aligned. And the first framework that comes to our mind is, of course, 2030 Agenda for Sustainable Development, which advocated 17 Sustainable Development Goals. We call it SDGs. So these 17 sustainable goals, they are interrelated, they are transformative, and they aim to do something big in the history of Earth. So for the first time, these 17 goals are adopted equally by the developing world, underdeveloped world, as well as the developed world. So these 17 sustainable development goals have several targets to be achieved, and we have to also demonstrate on the world stage that how we are achieving these targets. And for that, we have several indicators, and that indicators need a data. So what I'm trying to do here is I'm trying to tell you how important is the data in achieving or proving to the world that we are achieving the targets of sustainable development goals. The second framework is climate change. We call it Paris Agreement. And all the nations are committed to contribute to this particular agreement. And this is the only legal binding on the countries. And that takes us to third important international framework. It's a Sendai Framework for Disaster Risk Reduction, which aims to build a safer world, disaster resilient world. And these climate change agreements, disaster related agreements, and several other agreements related to social aspects and economic aspects and developmental aspects, all have become part of the Sustainable Development Goals. So we have the developmental goal on resilient citizen communities, which takes lots of elements from the Sendai framework for disaster risk reduction. We have goal number 13, which is a climate action, which takes lots of elements from the Paris Climate Change Agreement. So these goals are very, very comprehensive, and leaders of every nation have to go on the international platform and prove that the country is progressing in achieving these developmental goals. So there are lots of reviews, and we have to feed lots of data into the indicators of these goals. So one of the good things happened around these sustainable development goals, which did not happen many years before, is the sustainable development goals that are related to the environment have taken the foundational position or the prime position. That means the most important goals and key goals people consider today, or the countries consider today, are the goals related to the biosphere or the environment, such as life on land, life below water, or clean water, or the climate change. So these goals are basically taking care of the earth, the only home that we know that we can live. And by achieving these goals, we will be able to achieve the societal goals like quality education, gender parity, and several other things. And if we can achieve the societal goals, we can also achieve the economic goals like decent job or industry, innovation, infrastructure, these kind of goals. So with commencement of this 2030 Agenda for Sustainable Developments and Sustainable Development Goals, first time, in my opinion, we feel that most countries and their governance is in line or is concerned to protect the earth and its environment, because everyone has realized that our very existence depends on the how we protect or take care of our mother earth. So I come back to the data requirements. When a country has to go on the international platform and say that on the goal number 15, that is life on land, we have done these efforts and these are our achievements. The forest area has been increased, the biodiversity is more than before, whatever achievements they have done. They have to mention these achievements on various platforms that reviews the sustainable development goals. And these indicators, whatever claims countries make, need to be supported by the data. Unlike Millennium Development Goals, which were from 2005 to 2015, they were qualitative goals. But Sustainable Development Goals are making use of the quantitative data to prove that countries are on path to achieve these goals. And when it comes to the quantitative data, you also need a data transformation. And this is where we talk about evidence-based data. Obviously, everyone knows that data collected through the government records or by the NGOs or by the socioeconomic surveys, this data is not evidence-based. We trust that data if it is collected by the authentic department in authentic manner, but we have to trust that this data is authentic. That's all. But the data that comes from Earth observation in the form of maps, we often refer that data as a geospatial information. That particular information, that particular data is always evidence-based. So here we are going to talk about aspects of geospatial information, how we generate geospatial information using the space technologies, and what are the current advances that are transforming usage of that data by the last mile user. So when I talk of the geospatial information, I always feel that the major source of geospatial data is Earth observation. Yes, recently, most of the geospatial data is coming from the Earth observation. In the past, definitely we had to take the paper maps available from the various resources and convert that into the digital format, rectify it, and create the map layers in the GIS system, and that used to be geospatial information. But with great advancements in the space technologies, we have got number of Earth observation satellites available that provide data from global to the local level in very dynamic manner. So for example, if I get an Earth observation image, if I'm the forester, I can understand how much forest is there, whether forest is in good condition or it is degraded. I can understand the types of the forest, whether it is deciduous forest or dry deciduous forest, or it is scrub, or it is a luxuriant uh, teak forest, whatever, or it is grassland. If I am a soil scientist, I can understand the soil physiography, and then in each physiographic unit, I can take the soil samples and prepare the geospatial data of the soil series and soil types and the nutrients in the soil. If I'm geologist, I'll be able to derive the maps of the lineaments, faults, and geological features. If I'm a hydrologist, I can understand geomorphology, hydrological zonations, and I can do groundwater prospecting, and that becomes my geospatial information. If I'm an urban planner, I can see how cities are growing. I can understand the roof types. I can digitize the roads. I can digitize the city infrastructure, and I can generate lots of good geospatial information needed for town planning or the city planning. If I'm a coastal scientist, I can understand the coastal erosion, sea level monitoring, and mangroves, health of the mangroves, and so many things. If I'm an oceanographer, I can understand the sea temperatures, ocean currents. If I'm a climate scientist, I can understand the weather. I can understand how cyclones are coming to, at what speed it is moving, and all that. And what I'm trying to mention that whatever profession I have, satellite image has something to offer to me, and it generates lots of information, and which is the cheap and major source of the geospatial data. But it's whatever I just now talked is only about the Earth features. If we go beyond that, it also gives you the terrain information. That is, we call digital elevation model. Nowadays, high quality digital elevation models are available from the Earth observation. So currently, I'm looking at the forts, historical forts of Maharashtra, the state in India, and I have to create the stories of each of the fort and also prepare the disaster management plan. So I'm taking the digital elevation models of these forts because these forts are located on the rugged terrain on the top of the Sahyadri Hills in Maharashtra state. So I'm creating three-dimensional and fly-through models and actually capturing lots of information around that and depicting this for the decision makers. So lots of these things come from the satellite images. For weather monitoring, it's precipitation monitoring, soil moisture monitoring, monitoring the global vegetation conditions. There are a number of satellites. They keep producing the information in the form of maps, which is also important geospatial information available in dynamic form. You can also monitor the water bodies across the time scale and geographic scales and understand how particular water bodies are behaving in last 30 years, 40 years, 50 years, and how they will be in future. You can do some simulations. You can monitor the ocean currents. You can monitor the air pollution. Yes, there are sensors on the satellite. They can monitor air pollution and gives the maps that helps us to escape from the polluted air or take the measures for to mitigate those pollutants. There are a number of satellites which also gives the thermal data. They act like a thermometer in the space, And that helps us in understanding the heat waves, urban heat islands, and coping strategies with those kind of environmental problems. So I think I have given enough examples to tell you that lots of geospatial information available today is generated from the Earth observation data, whether it is from the space, that is satellite remote sensing, or it can be from the aerial photographs, or it can be also from the drones. But cheaply they are derived from the satellite remote sensing, because there are large number of satellites revolving around the world and they keep sending the images, and we can derive lots of information from that. So what are the important features of Earth observation and the geospatial information that we generate? Number one, you can get the coverage from global to local aspects. It means I can monitor the ocean currents or the climate phenomena like El Nino and predict how will be the monsoon rains in India and Asia, to the level that I can get the images where I can count the number of trees and number of houses in one city. So from global to local level, we can generate geospatial information using the Earth observation images. Now, the second important feature is this data is available in time series. We can go back to 50 to 60 years, right from 1960s, when Corona satellite, reconnaissance satellite, first reconnaissance satellite launched by United States. That data is now also made the public or open access. So from that time until now, until today, we can get the Earth observation images, and we can generate lots of thematic and geospatial information based on that. And this is particularly very, very useful because the data that is needed to contribute to the indicators of sustainable development goals, that need to be available not only for today but in the past. And in the past, many countries have not compiled their data very well. Data may not be interoperable, but 50 to 60 years of Earth observation images can tell you lots about what existed at that time, and that data can give the baseline. So we can see what was there yesterday, what is there today, and then we can simulate the future. Another very important aspect of this data is seeing the unseen. It means, suppose I want to monitor the erupting volcanoes in Indonesia. Even by flying through flight, we can only see the dust and smoke. But when we imagine that particular volcano with the satellite images, with the satellites, that goes beyond limitations of our human eyes, we can correctly see the magma and the fires. Similarly, we can detect the forest fires. And also by using very advanced Earth observation techniques like interferometric synthetic aperture radar, one can even regularly monitor the displacement of Earth. And that's how we can understand which cities are sinking and they will become more susceptible for the floods, or we can see any slopes that are destabilized, which may result into the landslides. So things that you don't see or don't perceive normally being on the ground can be seen and monitored using the Earth observation. And the maps derived from those observations are the key geospatial data sources for environmental planning, monitoring, and environmental communication, because this is the evidence-based data everyone can see. It can stand as an evidence. And there's nothing better than when you have evidence-based data, you can make your communication very, very effective, and your case can be very, very strong. Another very important feature is whatever data we get from Earth observation, it can be integrated with lots of other geospatial data. It can be the administrative units, country boundaries, district boundaries, state boundaries, village boundaries, or in the cities, the ward boundaries, roads, villages, houses, water bodies, socioeconomic information, population data, demographic information, underground infrastructure. So these are all GIS layers. We call it geospatial data layers. So all these things come in the form of maps. They sit on top of each other, make the data stack like data layers. And then through the vertical analysis and spatial analysis, one can derive the new insight, which we may not be able to derive using the tabular data sets or traditional data sets. Because what is absent in the traditional data set is the component of where. And that where component is very well addressed in the geospatial information. Suppose I want to understand, tell me the number of villages which are impacted by the dust emerging from the nearby mines. Traditional data sets fail. But when I have the map showing how dust is flowing, and if I have the village maps, I can precisely tell, or I can grade the villages based on how much they are exposed to the dust coming from the mine. So there are certain things that are impossible to be, observed through the traditional data sets, tabular data sets. The only geospatial data and geospatial information can give you this kind of insight. To this, another space technology joins, that is point navigation and time. Typically, we call it global positioning satellites. And this gives you another power of collecting the information at each point in real time, and as you navigate, information come to you, and it is time stamped information, time stamped. So this point navigation and time stamped information also becomes very important source of the geospatial data that you need for environmental monitoring, environmental planning. So today, anybody can take the mobile phone and collect the field data. You can also apply little advanced techniques like geofencing that ensures that the person who is collecting data actually has gone to the place and then collected. Otherwise, that data cannot be collected. This ensures the authenticity of data collected by the field persons. So people cannot cook the data, basically. So this is the important aspect that geospatial technology now contributes in making the field data very, very authentic. Then there are lots of allied technologies. So one of the strongest technology today available to us in recent years is IoT, Internet of Things. So there are a number of sensors that can monitor the air quality, that can monitor the soil moisture, and the elements in the soil. It can monitor the water levels, water quality. It can monitor the health of the vegetation. It can monitor all the weather, so automated weather stations. So these technologies are now available, and through the IoT, we can get that data at desired interval. And those data are all geo-referenced because each IoT unit that combines several sensors is also equipped with the time, point, and navigation. That is the GPS kind of technologies. And that gives you data that is linked to the latitude and longitude, and it becomes part of the geospatial information one needs for development and environmental monitoring or building the disaster resilience. So these are some of the very important sources of geospatial information. Uh, and as we discussed, that these are all evidence-based information because they are collected from the sources like Earth observation, which is not tampered data, or collected through the IoT methodologies, which is also untampered data. Today, many governments, they have embraced the 2030 Agenda for Sustainable Development. They are committed for Paris Climate Agreement. They have committed to achieve the disaster resilience by achieving the targets of the Sendai framework for disaster risk reduction. So increasingly, these governments are making up policies that are pro-environment or that are targeted to achieve the sustainable development. And these policies are resulting into the buzzwords that we hear these days, like carbon credits or green credits or ESG, environment, society, and governance compliance. For example, Government of India has now already launched the official notification of green credits. It means any individual, any organization, any village, any town, or any government, local government, if they are doing any pro-environment activities, they can document it well and they can get the green credits for that. So these things are going to become reality very soon once the policies come into the action. Carbon credits are already working in several countries very well. One of the important aspects of these policies and the credits that I mentioned is how well you document so that you can prove that I have generated these many green credits or these many carbon credits. And that needs the baseline, that needs the data that is continuously coming to you through Earth observation, through IoT, through the field surveys. And that data is one of the very important geospatial information that demonstrates that these many carbon credits or green credits we have generated. Because economics, the value, the price tag is associated with it. We need very strong data, robust data set to monitor all the parameters that determine how many green credits and carbon credits we have generated. Similar things go with ESG. Several industries now wants to become carbon neutral and water plus. And ESG envisages not only environmental compliance but also compliance to social ethics and the ethics in the governance. And this is where also you need lots of information. So countries are now trying to assess how much carbon stock they have generated over the years, how is their current carbon footprint, and how they can really neutralize their carbon footprint by cultivating additional plantations somewhere. And this is where we need continuous data on environmental aspects, on biodiversity aspects, on carbon capture capacity of the plants. So this goes on proving the how important is the geospatial information or the geospatial technologies, including Earth observation and other technologies I mentioned. It has underlined that. Now, what is the best technology offered in current situation? Last few years, we are talking about artificial intelligence, machine learning, gigamaps, and conversational artificial intelligence, conversational AI. Why I'm mentioning this? I started with my concern that any organization, any leader, or any government involved in their core business, they should be able to use all types of space-based Earth observation, geospatial information in their work. But this has not happened very well yet because the technology was difficult. It needed experts to work on it and provide the solutions. But advances in artificial intelligence and machine learning is changing the situation. It means today, whatever analysis approaches I want to formulate for deriving the new geospatial information, I can train my algorithms. We call it deep learning algorithms. I can use artificial intelligence. I can put the machine learning algorithms. I can make my models better and better. And for the user, they have to simply run the commands. They don't have to understand what layer I need to take for certain analysis, which satellite data to be used, which band has to be used, what is the index that I should have, I should generate. No, they don't need to understand all these things. All these things can be considered into the modeling, and whole thing can be automated, and user interface is given to the ultimate user, the end user, in such a matter that they simply say, okay, show me the change in plantation in last 10 years. Suppose one organization has started plantation and water conservation efforts, and they want to understand how the forest and agriculture situation changed in 10 years. They can simply ask the system the question, and the system goes into its databases. It takes the free database, open source databases, open source satellite images, it runs the algorithm, it finds the changes, it gives you the statistics, and it also gives you maps. These are some of the technologies we have already developed onto our indigenously built geoportal. And user can simply say, okay, show me the wildfires and give me the statistics of areas burned in last 6 months. The system will just go into wide databases, get the maps ready, and gives the statistics. So with advancement in all these technologies, now is the time, I insist, now is the time that we can take this technology to the benefit of all the grassroots stakeholder. We don't have to worry what is their core business, and they don't have to worry what are the technologies. They can simply use these technologies for their benefit. This also reminds me to add my last point. What is the new responsibility of geospatial professional? As a geospatial professional, we are expert in satellite remote sensing, digital image processing, or multi-layer analysis, and so many things. But now we have to be also expert in artificial intelligence, machine learning, IoT, GPS-based data collection, and generating the platforms that automate the processes for the end user. And we hand over the very user-friendly tool for our user. So this is the responsibility of now geospatial professionals. So I hope I have been able to cover almost all aspects of how important is the geospatial information, what are advantages of geospatial information over the traditional databases, what are the cheap and key sources to get the geospatial information in dynamic manner, how we integrate it, how other technologies like GPS, IoT contribute to new geospatial information, and how advances in frontier technologies like AI, ML is basically they are contributing to making geospatial technologies easy and accessible to the end users. I hope you enjoyed my talk, and I wish you all the best. Thank you.